Good morning everyone. Welcome back to another session of your science class. I hope you all are taking care of your online studies and preparing very well for your final exams. In today's video, I'll be sharing you some clips on few important topics from chapter number 16, that is electric current and its effects. So let's begin.
We simply have to connect the positive terminal of the cell with any one of the terminals of the bulb. And finally complete the circuit by connecting the negative terminal of the cell to the second terminal of the bulb. The bulb then glows. The word circuit is very important here. In this context, it will be electric circuit. In simple words, it is the path along which an electric current can flow. You can see here that a closed loop is formed. All the terminals of the electric cell and the bulb are occupied. So here the electric current is flowing along a closed path. We say that electric circuit is complete. But how exactly does electricity flow through the circuit? Basically, it's said that electricity or electric current is a flow of electrons in one direction. What really happens is that the negative terminal of the cell repels the electrons in the copper wire near it. So the electrons in a copper wire drift away from the terminal. But in the process, they repel their neighboring electrons. Or in other words, they transfer some of the energy to their neighboring electrons. So the neighboring electrons are also pushed away. They in turn further transfer the energy to their neighboring electrons. The process continues and the energy flows throughout the circuit. This flow of electrical energy is nothing but electric current. So these are the two ways to define electric current. But how does the energy flow through the bulb? The electrons in the copper wire transfer this energy to the electrons in metal rod connected to one of the terminals. This energy then flows through the rod, through the filament and out from the second terminal. So in this way, the energy is transferred through the bulb. But when the energy flows between the two ends of filament, it heats the filament up, which in turn glows and gives off light. So I hope that you're now clear about how the electricity travels through a circuit. But for how long will this energy keep flowing? The energy flows as long as the circuit is connected or until the cell dies out. So we learned that the circuit must be complete for the bulb to light up. But is this the only way for the circuit to be complete? Well, if we interchange the wires connected to the two terminals of the bulb, then the circuit is still complete. So the bulb will still glow. Now look at this circuit. Is it complete? No, it isn't. Not all the terminals of the system are occupied. For instance, this terminal is not connected to the circuit. Here both positive and negative terminals of the battery are connected to only one terminal of the bulb. So what's happening here? The energy is flowing from the negative terminal of the cell directly to the positive terminal of the cell. Not only will the bulb not glow, but it will get even worse. The battery might explode and may severely injure us. You should never connect the positive and negative terminals directly. This heats up the wire quickly and at the same time the battery also drains really fast. This is a symbol representing a battery which is a 1.5 volt cell. This bigger line represents a positive terminal and the small one represents a negative terminal. This symbol is used for the bulb connected in the circuit. It is just W written upside down in this way and enclosed in a circle. So if we were to draw this simple circuit using the symbols, then how would we do it? Just draw the symbols for the electric cell and the bulb first. Then using straight lines for wires, join them together. This is the circuit diagram representing this circuit. It was simple to draw, wasn't it? You can even show the direction of electric current in the circuit with arrowheads. So the electric current is flowing in this direction from the positive to the negative terminal of the cell. Let us look at this circuit now. How many components does this circuit have? Yes, 3. A bulb, cell and a switch. What is the symbol for switch? There are 2 symbols for a switch. This symbol is used when the switch is on and this symbol is used when the switch is off. If we were to draw a circuit diagram for this circuit, then here is what it will look like. Note that there will be 2 circuit diagrams for this. This one is when the switch is off and the electric current is not flowing through the circuit. We see that no arrowheads are shown here. This circuit diagram is when the switch is on. Here, the circuit is complete and the current is flowing. The arrowheads are used to show the direction of the electric current, which is always from the positive to the negative terminal of the battery. Now here is a question for you. We know that when the electric current flows between the 2 ends of the filament heats up. This heating up of the filament results in its glowing, and this is how we receive light from the bulb. But if this filament is broken, then will the bulb glow? No, it won't. This is because if the filament breaks, the circuit will be broken.
Heating effect of electric current. Students, when an electric current is passed through a metallic wire like filament of a bulb or coil of an electric heater, geyser, electric iron or room heater, the coil becomes hot and glowing. This is known as the heating effect of electric current. In this condition, they radiate heat and light. The amount of heat produced in a wire depends on its material, length and thickness. Thus, for different requirements, we use wires of different materials and different lengths and thicknesses. Electric fuse. Sometimes you may have seen the situation in your house that the fuse is blown off and the electric supply is cut off. Can you tell the reason for this? This is because of the enormous amount of heat produced wherever there is an excess flow of current due to short-circuiting, overloading or insulation failures of appliances. Safety fuse is a device that protects an electric circuit. The heating effect of electricity is used in this case. When the current drawn is beyond a certain value, the fuse wire gets overheated, melts and breaks the circuit. This prevents fire and damage to various electrical appliances. Fuses of different kinds are used for different purposes. Plug fuse is used in our houses. The plug fuse consists of 2 parts, namely, the porcelain casing and the porcelain grip. This fuse has a thin wire of tin and lead alloy, which has low melting point. Cartridge fuse is generally used in electrical appliances. Miniature circuit breaker or MCBs. Miniature circuit breaker or MCB is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by overload or short circuit. Whenever there is a fault in a circuit, MCB interrupts continuity to discontinue electrical flow immediately. It can be reset to resume normal operation. When an electric current is passed through a wire, it behaves like a magnet. Let us perform a simple experiment to understand it. Take a thin insulated copper wire and fix it in the north-south direction. Place a compass needle, which is a tiny magnet, under the wire. Connect the 2 ends of the wire to a battery. When no current is flowing in the wire, the magnetic needle is parallel to the wire and points in the usual north-south direction. The needle gets deflected from its north-south position when current is passed through the wire. When electric current is switched off, needle returns to its original position. This shows that an electric current produces a magnetic field around it. Let's perform a simple activity to show the magnetic effect of current. Take a long piece of flexible wire and wrap it around an iron nail. This forms an electromagnet. Connect the free ends of the wire to the terminals of a cell through a switch. Now, place some pins near the end of the nail and switch on the current. We see that the pins cling to the tip of the nail. When the current is switched off, the pins no longer are attracted to the nail. The coil in the above activity behaves like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. Thus, an electromagnet works on the magnetic effect of electric current. You must have observed cranes lifting heavy iron scraps in scrap yard. These lifts make use of electromagnets for lifting and transporting large masses of iron scrap, girders, plates, etc. It is also used to separate magnetic material from the junk. The main advantage of electromagnets over the normal magnets is that they can easily start and stop, and the strength of the magnetic field can be effectively controlled. Electromagnets is also used for magnetic resonance imaging, getting a detailed image of the inside of the body to diagnose a number of diseases. A variety of electrical devices such as electric bell, microphone, loudspeaker, etc. make use of electromagnet.